Good morning, everyone. My name is
Courtney Hodge, and I am a current master's student in the School of Data Science. I have the pleasure again to introduce this session. This is Building Rich RAG Systems with Docling, Unlocking Information from Tables, Images, and Complex Documents by Krishna, Rekapalli. Participants will learn how to harness Docling's advanced capabilities to build superior RAG systems that can understand and retrieve information from complex document elements that traditional tools might miss. Participants will learn how to handle complex documents, extract structured information, and create an efficient vector database for semantic search. The session will cover best practices for document parsing, chunking strategies, and integration with popular LLM frameworks. And to introduce Krishna a little bit more, Krishna is a senior data scientist at IBM's Watson X AI, Solution Architect Center for Excellence, specializing in designing and implementing enterprise-scale LLM-powered AI solutions and agentic workflow. As a reminder, please hold questions for the end of the session, but if you have a code question for Krishna, please ask. Also, PyData recordings and slides will be available after the conference and will also be emailed to you directly following. Thank you so much, and I will hand it over to Krishna.
Thanks, Courtney. Hello, everyone. I'm Krishna. I work at IBM Watson's Solution Architecture team, where I help clients build AI solutions using LLMs, and in a lot of cases that we work with clients, there are a lot of documents like PDFs and company information. Most of it is say HR documents or any information like that is either locked in a lot of PDF files or HTML files. So to solve this issue, IBM Research has worked on an open source a framework and also a Python library called Docling. It was originally developed by IBM Research, the original in Switzerland, but I am one of the users of the library. So I want once they open sourced it, I thought it's a good idea to also share it with the community and help all of us get better information out of our PDFs. A short intro of Docling. It helps us parse multiple document formats, and it has advanced layout understanding model. So the thing is, you can feed a whole PDF or a document to a large language model or state-of-the-art model and do this parsing for you, but many times it may be an over-engineered solution. And what Docling does really well is it has a multiple fit-to-purpose models under the hood, where for layout understanding there is one model, and there is one table understanding model, there is an image classification model, and there are also newly introduced formula and equation extraction models, which all of them are open source and available on Hugging Face. The pre-trained weights are available on Hugging Face, and you have this two. It's also available as CLI and Python library, depending on what your comfort is. So if you see a typical research paper or a PDF, it has a lot of metadata that is you're parsing it through an out-of-the-box library. You may not capture all the data because there is two-column structure. There are images. There is a hierarchy. There's a title, abstract, and everything. And this is not straightforward if you just feed it to a out-of-the-box PDF parser. So if, like I mentioned, the out-of-the-box PDF parsers many times they're pretty fast. But many times they are incomplete because the structure is lost. Sometimes the tables are not captured well, and there's a lot of noise in the output if you just use it. Um, you have, but on the other hand, like I mentioned, if you put it in the state-of-the-art LLM, it can do a good job, but there is a problem with, first of all, it's very costly, and there is also a chance that they can uh, hallucinate when you send huge document sets and say if you want 200-page PDF, it may not give you consistent results. That's where I think Docling works really well. You can run it on a local machine because all the models that work behind are pretty small and they can ideally run on a CPU machine. You don't need an expensive GPU to run them. And while you can also accelerate, if you have any cheaper GPUs, you can always set the accelerator under the configuration settings. And this you get a structured output. So it does actually a good balance of using fit to purpose models to parse each of them, and particularly these are smaller models that can run on a user's machine or CPU. So and so Docling, when once you uh, parse a document, what builds something called a Docling data model, which is a standardized data model that is output comes as an output of once you process a document. So it has this hierarchical structure and a very rich captured metadata with some relationships also captured. So that way, once you use it downstream in your process, you can um, you can do a better job when you're doing saving it in a vector database, or if you're building a relationship graph or something like that. You can use this rich Docling document um, to have for your downstream processing. And just how the architecture works is for PDF files. Like I said, there is an OCR model optional. There is a layout analysis model and a table structure capturing model, and all of them work in a sequential manner. And then finally, there is a post processing where everything is put together. There are overlapping tables or overlapping layouts. The assembly part will take care of that. Finally, you get um, a, a Docling document that you can use for. You can export it as a JSON, which will be a lossless. But if you export it as Markdown or HTML, some of the metadata is lost. Or you can, in the downstream, you can either use it for chunking for a RAG, if you're using a RAG pipeline, or if you're using structured data, you want to save it in structured database and keep the text in a separate place, you can do that too. Because the Docling document gives you freedom to do that. So the lab resources are in this URL. You can go to this URL to start working with it. So I'm going to use Collab here for all the notebooks that I put here. So these are available originally. Most of them are available in the Docling examples page, so you can the much richer advanced examples. Yeah. So in the Docling project page, there are a set of examples and more advanced examples if you want. But yeah, for this tutorial, I put together some of them here for the ease of use. One
Can
thing
you
I've
show the tiny URL again?
and I think I also linked that technical paper in the so the technical paper goes into a deeper detail on how what models are behind and also lists the original people who developed and open sourced it from IBM Research Zurich Labs.
Can you show the URL again?
Yes.
Looks like a lot of people.
Sorry. Yeah. Okay. So the repo URL is also in the event agenda actually, but let me actually go back to here. So it's tiny URL / PyData dash docling. I'll wait for anyone who wants to.
Yeah, there's a link to it in the conference schedule.
Yeah, in the conference schedule I added the Git repo in case if so I'll quickly touch up on the technical paper. You can that's also linked within the repository. If you want, if you're interested later, you uh, can review this. But yeah, we already went through this overall architecture flow. What I wanted to show is yeah, here there is more information on what small models are behind each step. So there is a layout analysis model and the table structure recognition model, and the I think for OCR at least uses out of the box easy OCR. It's an open source library, and these models are available under Hugging Face. If you go Docling models, and you can find all the rates for these models under model artifacts. So, uh, yeah, you can all of the models are interesting access to you can go and download them. But when you install this Python library, what happens is these models are also downloaded onto your machine, and you try to run any document parsing, so you don't have to worry about that. But if you're curious, that's where all the models are. And the report also touches on some performance tests compared to other frameworks. So you can see on a Intel CPU versus M3 Max versus a L4 GPU, the comparison of Docling versus other competitive or other libraries that are available, which can do the same thing. And compared to them, Docling is faster. And also to add, because Docling is supposed to be used as a pre-processing step, there are LangChain and Llama index extensions for Docling, so you can download those libraries and use the output of this Docling document into your next step, which is chunking or anything for a RAG pipeline. Let me switch to the repository now. The repository, the first output, Docling 101, and you can collab or you can use your Python environment to run it. And then a small typo here. This cell will run for a little bit of time because it downloads the models that Docling needs for the processing of documents. The simplest way to use is using the straightforward document converter class, where you can pass a local PDF file, or you can pass a URL, and see what it says. So there is a CLI, nice CLI reference if you want more your choice of usages to command line. Once you click install Docling, you can interact with it by using this CLI directory. And here this lays out all the options you can use, say to do OCR or not to do OCR. By default, OCR is turned to true, and which OCR engine you want to use, if you want to switch something, and the PDF backend to use. There is a default PDF backend that Docling comes with, but if you want to use something else, you have other choice there. And for table mode, I think there are two models: the fast model and accurate model. And accurate is a little bit bigger model, so it will take increase your processing time. And there is enrich formula yes or no option. By default it is false. The formula enrichment is another model, so it will download another model for you, which will also increase the processing time. Well, if you run into any issues running these notebooks, let me know. We can figure out. Here, what I did is I exported to the Markdown, but I think there is here I can also pass much advanced settings if I want to use say vision language models, and Docling recently released a smaller vision language model. If you go to the Docling Hugging Face page, it's called Small Docling, which is like 256 million model, which is pretty good and it's trained on recognizing and describing document images like the paragraphs or formulas as well. And in this notebook, the advanced usage section, we can pass a lot of pipeline options here. Say, I can set do OCR to true or false, do table structure. Pipeline options is what I can use to pass all these settings. And here I said pipeline options do picture description to true. Picture description to true when I turn it on. it will automatically use the small Docling model, or there is an option to pick any other out of the box small vision language models if you want. That you can change in the settings. So here I set like do picture description to true, and this is the a small prompt I passed to the VLM model that is generating the picture descriptions here. And like I said, you can also use the accelerator on your device, and there's the accelerator device you can set to auto, which will detect here on Mac. Use MPS to accelerate the calculations. Or in this case, if you're on Colab, then you can you can change the runtime to a smaller GPU runtimes, which will in the change runtime type. You can change it before you start the notebook, and it will automatically detect the runtime and use it for calculations. But in this case, I'm using simplicity. Should not detect any accelerator on my device. And because it's using the vision language model, it will take much longer here to process this document. So the document I'm passing is the documentation report itself. So it has some bar pie charts and some tables. So the picture description here should add all that metadata by describing that image, and it adds that as an additional metadata here.
So my understanding is that for the image processing, that's where an LLM comes in to basically do the description piece. But for purely text or PDF file, like we just saw in the first example, it skips over images and uses OCR for the rest?
Yes, it
Only OCR.
uses OCR, and to recognize the table structure and understand the layout, it still uses some vision transform based models, but much simpler. They're not as big as a typical LLM is. So if you see the sizes here, that's pretty.
Okay.
Also, when it does the initial analysis of the document, when I did the markdown, so if you see here, it leaves placeholders for images. Just says that it is an image, but because when you export to markdown, it loses some of the structure.
Mhm.
But if I export the original one to JSON, just making sure that I didn't use the same, same variable name.
That one has been running a long time.
Because of the VLM that I turned on, and this is a gives me a smaller machine here. That's the
I have a question.
Yeah.
So if I want to classify a document like a legal document versus like an invoice or like a contract, can it do that?
So document, you're saying the classification of the nature of the document itself? I
Type of the
don't
document.
think so. I don't think it should classify. Even a document, it can capture all the within the document. If this is an image or a bar chart, that classification it can do and capture it, and also it does a uh, captures some bounding boxes. So let me show you a good example which shows. So, good thing with this is yeah, it also captures the bounding boxes of different sections. So that way you can do visual grounding if you want to say show the sources of where you pick the answer from and give this is the section where the LLM found the answer. And that things it can do, but I don't think it exactly classifies this as a W2 tax document or something else. Yeah, I don't think so.
Can it read the, for example, since you brought up W2, right? So can we read the line inside a W2, for example, this box is like a wages, this is like, can it do
So
that?
I think there that feature of on top of my head may not exist, but there is some work being done here to capture the key value pairs, like you mentioned. I don't know if it is it's released in the current Docling version because in the document um, structure here, you can definitely see a key value section as well. I'll come back to you. There is one question.
So I just had a question about like how accurate are these sort of PDF extraction tools that use LLMs? Because in the past I'd used I think Llama Parse to extract PDFs, but it was not consistent enough for like formatting the tables and everything, and so I ended up just going with PyPDF2 and then using regex to like manually find the patterns where I wanted to, because at least it output a more consistent like output.
Yeah, I think that's where using different model for each of the table formatter or table recognition model here. What it does is starts with it's trained on different images where tables are there, and uh, the results are posted in the Hugging Face if you want to see. But yeah, as far as I know, Docling does a really good job of detecting the tables. But and I know with these models and any model, the accuracies are around 90% when they did 90+% is what I remember. But there is still a chance of if the table is too complex, it may have some issues. So it's not fully like perfect translation from PDF.
Yeah, well, that was the like problem that I had, was because I was doing this for a company where they have user data and like it
Yeah.
has to be 100% correct. So it wasn't possible with that. I know that LLMs aren't perfect.
Yeah, I think yeah, this definitely, to my experience, yeah, it does pretty good at most of the tables that I have seen, but there is a chance like yeah,
What
Did-
language model does Docling use?
what is that?
What language model does Docling use?
So Docling for table recognition and everything, it has homegrown models that they developed. So the table former. So if you wanna go to the Docling, here are some of the metrics, right? You see, the table former is the accuracy on most of the metrics are 95 or 90% on different uh, table data sets for benchmarks.
You have different lengths. Like, can you have rows that are variable length? Does it handle that well? Because I've had issues with that.
the table is like some rows
Yeah,
having
like normally like a row is just one line, but then randomly it's 2, 5, 8 lines.
I think it should maybe what I have seen there are multiple lines in a cell
Like there's text in a cell, and normally
Yeah.
it's like, you know, a couple words, but sometimes it's like multiple sentences
Multiple.
or a paragraph. That'll throw things off, right? Because it's used to a certain format,
Mm.
and then maybe the contrast is not right, or it's not picking up on the fact that it, you know, done light, dark, to try and differentiate cells.
that's I think it should, but yeah,
I'll try it.
we will try and see. Yeah, it
What
should.
about variable column widths? And
Variable-
that's really tricky.
Yeah, variable column width. So in the papers that I have parsed, there were some examples with variable column widths, and it did a fine job. I don't know
Like
if it is available here, but yeah,
Oh.
we can certainly give it a try there. Sorry, here there's a question.
Sure, there were multiple questions that were asked that were similar to what I was gonna ask, but I do have a follow-up because sometimes in a PDF, people will actually put in an image of a table.
Yeah.
Is it pretty good at handling that or, yeah?
Yes, that is where the OCR can be pretty helpful, and also, so what Docling also does is even the table former model, it takes images of the PDF at a lower resolution and tries to detect tables from there. So that's where he said
Yeah,
that
some,
these should be covered there.
Excuse me. So does the pie chart reflect some differential performance with regard to the knowledge domain, or the the pie chart in the paper?
The pie chart.
Yeah, does that mean that it will perform better in some specific knowledge domain as opposed to other, or?
Oh, okay. So I think this talks about the training data.
Can you make it a little wider?
Let me see. Yeah.
Let's see it.
I don't remember on top of my head if this is the validation set or the training set for
this is
that.
right up.
There's one right here.
Oh, there is.
Should do well on the typical reports that we see on research papers. That's where this Docling shines.
So it does reflect differential performance.
So when you say differential performance, like
Yeah.
in
So if you
certain
give it
tasks,
if you give it PDF of some scientific field, it will perform less than if you give it some annual report. Is that what that means?
maybe let me actually I don't remember. I can check and find out on that. If this
I think it's
is
just in the training set, the number of documents, right?
Yeah.
I think that's just the number of documents in the training set, so maybe it's related to that.
Yeah, but I'm wondering what will be the implications in terms of performance,
Yeah.
because, right?
so you're saying if it is tested on some category that is not trained on, like
Right, like large language models, like if a model is trained on
How-
some
how well
specific
it
language,
generalizes
like
on-
DeepSeek is
Yeah.
trained 40% on Mandarin
yeah.
as opposed to English, so there is some differential performance just related to the fact that the training
How well it
has
generalizes.
different
Yeah.
structure, right?
Yeah. I think, yeah, that might be a good thing to, you can get back to the original team and figure out, find out an answer for that. I don't have it on top of my head, yeah. This has been running forever because it's a small machine. So let me stop this cell and
Do the HR records that you actually work with have like table structures? Is that partly the in your actual work, does it pull fairly well from the tables in there?
Yes.
Okay.
In the cases that we use for text extraction and getting most of the table context well, does a very good job in the cases that we have released upon.
And for charts, does it interpret the meaning or the results of a chart, like an upward trend or a maximum value?
So I think that is where the new development with the small Docling vision model is supposed to be doing, because it's particularly trained on these cases where bar charts or formulas need to be parsed. Let me actually quickly show you on this Hugging Face page, because it has say, so this, I have some credit for if the free account you get to use this for some inferences. So this is one example of the small 250 million model, which is trying to convert a bar chart, image bar chart into a structured table in this markdown. Similarly, there are more examples here where there is also a formula to formula conversion. There also the vision language model does a fairly good job of picking the formula. And here in the settings, I mean, if you don't want to use the small Docling, you can use something of your choice too. VLM is vision language model setting is something that you can configure, and here in the examples page there are examples for using Grenade 2 billion model, which is an IBM's smaller vision language model, which should on paper, because it's a bigger model, might generalize better.
With the example notebook, do we need to specify like a Hugging Face key?
Actually, it should, I mean, it should not. When I ran in my machine, it did not ask for Hugging Face key, because all it is doing is to pull the model, not doing any inference. But when you try to run it, is it asking for Hugging Face key?
No, but I'm just on the 6 cell. Just keeps saying trying to resume download. It's suddenly with Hugging Face. It's
Could be possible that because when I did a mixed testing on my, let me see if it runs into same problem on my machine. It should not require the Hugging Face key. It's like whenever you pull an embedding model from Hugging Face transformers, it's very similar. But it should not be asking for that. But yeah, one thing I want to also focus on is that once you parse a document, convert a document, the resulting document type is Docling document, and if you do
the element tree, maybe?
Export to take. I think that's that would be the this is the full the bounding boxes like it's like this bounding boxes of different elements there is a key value items here which is left empty for now. I think the in the future releases there may be also extension here there's key value pairs. In typical PDF, it should take 2 to 3 seconds per page with normal settings without VLMs. But if you use VLMs or OCR, it may take a little longer to process each page of the PDF. Yeah. There are any more questions on the first one? Go to the second one, which goes into the Docling line chain extension, which is we want to use it downstream for any RAG pipelines.
I have a use case where I want to extract handwritten data from a big record form,
Those,
like a doctor's office or something.
Yeah.
How does small Docling perform on handwritten text?
Handwritten data set, not aware of how it stands. Let me see. I don't know if they released a research paper on this. Talks a lot about.
Or I guess just have you had experience with that? Or
Yeah, handwritten. We don't actually. In my case, I did not come across a lot of handwritten, but within IBM there are some in-house OCR tools that we use for. Works extensively with more languages actually for handwritten digits. So yeah, we did not use Docling for that. The second option here, we go a little bit to a next step where, say, you use Docling for your pre-processing. This is a vanilla RAG flow you see on the notebook here. Image here where it, put all the once you pre-process the documents, you save the vector into a vector DB and then query for semantic similarity when the user question comes. And you send this pick relevant documents from the semantic search and send this whole thing to a language model. You have a system prompt and the user query in the context that needs to answer from. So here, this notebook has, you can again open Colab. For the LLM part, you may need a Hugging Face token or replicate token. So I have added in the Git repository some directions in here. if you want to set up the Hugging Face or replicate tokens, added some instructions here. So with replicate, you get I think some 50 cents or 20 cents credit that you can run small models for at least a decent number of inferences, and you can sign up with your GitHub and access the tokens under replicate tokens. So it's under the setup directory. Same with Hugging Face, you get like 20 cents credit if you are using it for the first time. Or instead, if you want to use local LLM serving, Olama is the better way forward. But yeah, when you're using Olama, just keep in mind that use a smaller model, like a 1 billion or up to 8 billion is maybe okay. A quantized 8 billion, it uses your system.
Do you need to then specify that in the notebook somewhere that you're using Olama?
Yes. So if you're running it on local, Olama is much not on Colab. If you're running notebook on your machine,
Yeah.
Olama is much easier because and the Olama serve and starts an Olama server. It starts an Olama server and so once you download Olama, you run the Olama server, start the server, and run the Olama, and the model name. So if it doesn't exist in your local, it will pull back to you. It will start a local inference endpoint, and the inference endpoint should be yeah. But once you start that here, there is, if you scroll down here, the drag option comes. Here you inference provider cell where you can pass. If you pass Olama, it looks for a local Olama that model exists. So here I already passed Llama 3.21 billion. And if I select Olama option, it should automatically try to use the local inference. So let me actually this.
An operational model using your recognition diagram. If you wanted to carve out policies, say like HR data, say
user fee received this, staff that received this, what I would want to use the policy. Would archive go for the document in that architecture, or would you be able to pass it on to
I did not fully capture the question. Can you?
Yeah, so like if we had a couple of different types of HR documents, say an employee handbook, you know, PTO policy, but also HR documents around compensation. I, as a non-HR specialist, should be able to get RAG from the employee handbook, but not see other people's salaries. Does this have, where would the controls go? Is that your question?
Correct, yeah.
What? Okay.
Can it read the employee handbook to know this is employee information data, but compensation in that same database, that same source, should not be included in the search?
Yeah, I think that's for that problem. I think Docling out of the box doesn't provide you these. I think these you need to definitely capture as part of the metadata. Say the source document, depending on who has the access to the source document, all the derived documents should have the same access controls, and for that, Docling doesn't give you any of those, but you may need to use some kind of data provenance framework to do that. And all the secondary derivations should also have the same level of control or permissions in this case. But
So the source
that's
of data would need to stop it before you became into Docling at that point in time, depending on who asked the question. I may be asking this incorrectly.
So I guess if I heard you right, if we wanted to, like Docling for the sort of default RAG setup is going to take all the documents you give it and make them searchable. And so if we wanted to add that metadata, we'd want to do that on like document ingest time?
I think so. During the document ingest time, you make sure that add appropriate metadata, and in this case, because we are giving it a folder of PDFs, but who does it belong to? It doesn't really. Not really worrying about that, but in an enterprise, we may need to make sure that the permissions are properly set up.
And can you query it and ask for a subset of the data to export, like with that HR data, give me all the records on this person with dates? Can it do that? Like basically turn that into a time series? So it reads in a bunch of PDFs over time, right? The last 10 years of data, and you're like, give me John Smith's records. Like, put it in a table and export. Can they do that?
I don't think that we need much more mature overall solution to do that. Because all documents that help you, say if you have some PDFs with a much richer form of text or JSON, now with that Docling document, like you said, we have to enrich it even more, like add much more richer fields and permission fields depending on if this is a plausible PII or employee data. I have to process it, like because once you get this JSON of parsed text, now you may have to pass it through another level of refinement and say there are structured data tables. I will save that in a different place, and if this belongs to an employee and a PII, I should have a certain different control over it. I think that needs a much extensive solution than what comes out of Docling.
So at the end of the day, you're saying that there's no federation in Docling, right?
Federation, So when you say federation,
PII or like document streamline, but are you planning to add something like that where inside the pipeline you can provide a federation, let's say library function or something like that? Are there any plans?
Because I'm not originally from the IBM research team that developed this, so but I can take the question back to them. at least from what I have, yeah, I'll find out more from them and figure out how that works. But that's an interesting use case. So one thing here, Docling is the extension. So Docling provides if you want to integrate this line chain, and there is a hybrid chunker within that is shipped with the Docling library, which once you have the extracted document content, the hybrid chunker will help you create a better chunks than what comes out of a typical hierarchical chunking. So there are more examples of that in the documentation, but once we go through this, we can see. Okay. Yes. The only issue is when you try to write for the first time, it will probably watch. Like it's to solve certain issues with respect to the model. Docling recently came up with Docling Serve, where you can stand up a Docker API, as in this whole service as an API endpoint within your organization, and that way people can send response to that server to do the document processing. Yeah, certainly when you're trying to run it on your machine, for the first time it just takes much longer to download these models. And in this case, I'm using a local Milvus, Milvus DB to store all my document chunks. It is lightweight and you can run it on your machine. Don't have any problems. Let me know if you run into any issues here. PC is trying to.
So are you running your own vector database as well? Does Docling have its own flavor of vector database?
Docling doesn't have its own flavor of vector database. Yeah, all it does is it once you get the Docling document, and then the next steps either you use here in this case I'm using Milvus, so you can use any of your vector DBs of your choice.
While it's loading, would you be willing to talk a little bit more about what some of the advantages are of using the Docling document format compared to other chunking strategies? Because it seems really good for like multimodal or like documents with a lot of different stuff to like really split the parts out. But then if you're gonna fit that into chunks in a database anyways, I'm curious what that actually gets.
Yeah, so that's what I've been thinking recently, where the Docling document is very rich, and if you are trying to fit it in a typical vector DB, it doesn't, it loses certain value of it. So that is where using a very hybrid approach of save the structured data, capture the metadata, keep the mapping, and save it in a different place, and while retrieving you use a hybrid strategy of not just asking the vector DB for semantic search, but mix of some hybrid search and also using some structured data as well. I think that's where your value is. And I haven't explored this, but I wanted to explore how Docling document really works in case of knowledge graph, as all the relationships are properly established, how heading and tables are mapped. I haven't tried that. I want to give it a try after.
Sorry, can you repeat that? I have interest in knowledge graph. What were you saying about the knowledge graph?
No, so because the Docling document
Yeah.
captures the hierarchy, the relationships between, like it has mappings of what all the sections are. So it would be interesting to try to use a graph fragment kind of solution, starting from the Docling document, which is very rich because like one of the questions asked, if you try to when you try to fit it in a typical vector database, how the value is lost.
Right.
Structure is.
So you got the hierarchy.
Yes, some hierarchy is captured, but not entirely because you're chunking it.
Am I understanding it right that the Docling document format, it like you're basically for say one page of a PDF, it's taking that and turning it into XML, and each bit gets sort of brought out as a piece in the like XML or JSON, and you have that richness.
And it also has the if I can show you, there are different. Let's see. The first notebook has. Yeah, if you see here, it's a higher level view of how the Docling document is capturing the information. It captures the body, the groups, text, pictures, tables into different categories, and there is also some provenance information. Like I said, the bounding boxes are also captured. Yeah, all that you can use better if you are not using just a vector database in this case.
And in that way, so you can do like different types of search. So if you had like a image
much.
search, you could search through the images and then find where in the document that was. Use that to map to the page. And for the text extraction part, does the Docling document format when that's generated from a model, does it store like confidence or probability in accuracy?
For tables, I saw there is a confidence score coming out of it, but for I think OCR also should have some confidence. But anyway, Docling is using out of the box OCR.
So that means that if we were doing this for a lot of documents, we could actually look at that metadata in the document format and identify the places where the model is not confident, and then either flag those for human review or get a bigger model on them. There's another question.
I have a question. So, how accurate is it with the latex, format style? Because if you are working on
so Docling has its formula and whole understanding model that's the release. I haven't in my practice I haven't come across a lot of latex documents having latex, but I don't know how. I know that this small document, the new model, edition model, is specifically trained on scientific documents, so it should be doing pretty good there. Exact performance metrics or benchmarks. I don't have. Cool, thank you. There's this. I have changed the LLM reference provider. Solana. Because it's in this case I'm using we have a hugging face or replicate API token is change that in settings. Use HM for Ulama. If you say in some cases where you want a better along with the answer that the model produces, if you want to visually show the users where the chunks are extracted from, that is where some extracted metadata like this will be useful. So like I mentioned before, there are some bounding box information that default is easy. It's captured as part of the metadata, the page numbers. So to give more confidence to the users on the answers are extracted from, we can use this visual profiling. Once the answers are out, along with the references, you can show exact locations if you want using the bounding box information. That's a little bit of the visual profiling. Want to run that? Yeah, let me know if you are having any issues running this in the Rag notebook, or if you want me to expand. One thing is that hybrid chunker tries to by what we call is token array, it tries to modify the chunks a little bit as much as possible, tries to put the sentences in the complete form possible. That's where the Docling helps us to perform better chunking than out of the box chunking methods.
Are headers and sections captured in the metadata?
Yes. Source and
section with the content wraps across pages, does it capture that?
Yes, like that's where the first model, like when tries, so what is that? One of the models that Docling uses for the first step, it tries to look at the document layout as a whole and try once and at the merging step, if there are any overlapping sections, it tries to merge them together so that if a section spans multiple pages, it should be able to still capture that merge.
And it does that because it just assumes the section rolls until another section head is given. Like in the middle of one page, it says, you know, in all caps, section 2, and then there's a bunch of stuff, and then it goes to the next page. It doesn't let you know that's still section 2. Is that kind of metadata continuing to be captured that next page? Or is it captured?
So, say you're saying.
You know, like a document has sections 1 through 10. It's different stuff in the same general area of the document, right? We would like to know, hey, give me just section 1 from this document, right? I just want to get what it says in section 1, right? Which is different. So I want to know if that metadata is captured for tables or text that occurs there. But then, you know, a common format is that data then goes on for another few pages, but it may not let you know on the next page this is still section 1. To the reader, it's obvious that it's section 1. Is that being captured?
I think so. It does because when you look at many research papers or any document here, like section spanning multiple pages is such a common occurrence, right? So it should do that without any problems.
Excuse me, question if I could. How's that defined? How's it get so exactly in what section? You have to specify the exact coordinates, or how's that work?
Yeah, it's just giving, like when you try to pre-process it in the first step, yeah, it tries to extract the exact location of that. So from the PDF images, so like I mentioned, it uses the images of PDF to extract the sections and layouts. From that, yeah, it picks the metadata is captured where the bounding box exact coordinates or relative coordinates are captured here in the metadata.
So I was looking at the amount of parameters for the second cell, which is image scale, and I am trying to look at the Docling documentation, and I haven't did a Google search for image scale. Is there a good documentation link that we can refer to, because I wasn't able to find it in the documentation?
Yeah, so
other than looking at repository to see
yeah, I came across while using it. Yeah, there are some gaps like you mentioned. The PDF options were also the documentation really did not capture all the available options. That is where the more contributions are being welcomed. So recently, Docling joined the Linux Foundation, so hoping that and the community will help improve the documentation.
Just a quick question around taking this system to production. So I assume this is something you've done in different customer environments with on-prem deployments. So yeah, can you talk through some of the challenges or what you've done to take this Jupyter notebook and put it in production, whether it's in on-prem environments or even on the cloud? Are there any learnings you can share for people who might want to do that?
Yeah, sure. And within what we do at work, the Docling usage is kind of a bigger document extraction set of API capabilities within LLM. So we directly use those endpoints when we do the production workflows. Because, like I mentioned, there are more OCR capabilities that are in-house, and this is used as one of the components that help us through the flow. And when it comes to production flows, definitely this new Docling serve kind of solution architecture where you stand up this as a server and you can scale your compute that and use this as an API endpoint.
I see.
That would make more sense.
So there's like Docker containers and
Yeah. So that is also being it's a very recent development with Docling. So yeah, that's where you want to that's more fit for production if you want to use this as a service, and then like yeah, you have these nice convert file endpoints and manage the service scale to the file. So one challenge that I came across is when it comes to different languages, I think there were some issues. So the OCR out of the box only supports few languages right now, English and a couple of other languages. But I definitely had issues. There are documents with Hebrew and that are supported by this library out of the box. That's where still the gap is.
So when you're leveraging the visual grounding functionality, this is more of just like to almost circle back and test like where exactly your data has been fetched from, right?
Yeah, that's exactly in a RAG use case. Typically, it is showing the references and page numbers is one thing, and this visually shows you exactly the section which the LLM used to pick the answer from. Yeah, just to give more confidence to the users, it could be helpful.
So I'm looking at the code here and how it's kind of really just like annotating the boundaries for the highlighted content. But on the back end, how is it done? Is it like calculating pixel? Like basically, how do you understand what the model is looking at? Like, is it giving you like a range of pixels that then are being mapped down to like exact dimensions? Like, how does it know to like, basically put a bound around the exact chunk?
Rather than exact chunk, I think it shows like again this is so chunking comes after you do the initial pre-processing, right? So I think this still shows the overarching bigger section the chunk may belong to. So within this there may be sub chunks where like two chunks that go only one of the chunk might be used, but it shows the overall paragraph that the answer came from. But like you said, it may not show you the exact chunk and line number visually yet.
Yeah, sorry, you're right, I understand. So basically, my question then is, how does it know the exact, like to select basically the exact piece of content?
Yeah, so that is where the very first model, the layout information model, tries, which is takes the images of the PDF at a lower scale and tries to draw bounding boxes and tries to understand. It's trained on some images with a lot of research papers and documents. So using that, the model is able to identify the paragraphs or pictures, outlines,
I see.
and draw bounding boxes.
So it's not really working with any kind of image metadata, like pixels and stuff like that.
The input is PDF image.
Okay.
So you are giving a low quality PDF image to the model and it gives out all the bounding boxes.
Understood.
It's similar to I think any of the vision models that identify objects within an image and draw bounding boxes. But because in this case you're capturing the metadata here, the image input, it tries to use a very low quality image to just run the model fast.
Super cool. Thank you.
You were talking about the knowledge graph earlier. There's something about, I looked at some of the code, there's triplet and then there's a hierarchical chunker. Is that some of what you're referring to with how that could be used to enable the hierarchy? I saw something. I just went through the code and I saw something about a hierarchical versus a hybrid chunker.
Oh yeah. So hierarchical chunking is, I think, it comes like based on the headings and sections interest. The chunking based on that, and the hybrid chunker what it does is once that is builds on top of the hierarchical chunking and tries to adjust the if there is incomplete text here, it tries to adjust within the chunks to give it as much as possible. Try to capture the meaning in one chunk if possible within the limitations of the embedding model. And yeah, I remember like this page here, hierarchical chunking. It goes deep into the example of how it does it and how it little bit adjusts the chunks. Like the above one is 55 tokens, but after hybrid chunking, it gives you 56 tokens because it adjusts the tokens a little bit. And this example shows exactly where. And also it tries to undersize chunks if it is required. So, a good example can be. Yeah, one of like much simpler example where like here in this case there is only words and here it just adds IPM words to add to make it much semantically better.
So assuming that you have like Olama running in an air-gapped environment, this is like your most ideal option for, you know, like running something completely on-prem in an air-gapped setting, right?
Technical report also covers that, where because these models you can very small completely run them air gapped if you want to.
From a performance standpoint, right? It's best from a performance standpoint.
From a performance standpoint, like
Yeah, sorry, just going off the earlier question, like the preferential use case is to have Olama, and that's for performance standpoint.
I would say not Olama because it takes so long for inference,
Oh,
but like
okay.
in an air-gapped environment, it would be your only option, really.
Understood, yeah, that's why I wanted to clarify. Awesome, thank you.
that's just for the LLM inference though, right? I mean, you can also like have something like VLLM run it on your if you're in a production use case. So there are other serving runtimes that are much more which you can use for complete air gapped environments. Because end of the day you can run the llama model or anything. The weights are open. You can get pull the weight from having place. Use any of the not just Olama. There are other runtimes that are more optimum for using the GPU. Use better like VLLM. That is what we have production used for some of the clients. So it should be that would be a better choice.
You can pull that from Honeycraze, is that right?
So so VLLM is the runtime actually. It's an inference runtime. So that's also an open source project, and it has more advantages than Olama if you're using a production.
Does Docling support extensions for like different file extensions? I'm thinking like medical records with different file format extensions. Like, does it architecturally support more fine tuning for different files, but also maybe even like, I don't know, putting in more specific business context into these parsers, right? Because like ideally, we want to build off the base that it's created, but to our organization's needs or our customers' needs. Does the framework have any examples of other people doing that, or is it not quite there?
Yeah, not I am that's an interesting use case where I can certainly can reach out to the team Switzerland and see they're working on something similar, but extending it in the future.
Or even learn the open source community to set and play with their building blocks.
Yeah, that would be interesting way to extend this.
I guess in an air-gapped environment, the models, I guess, how would you handle to deploy those because it has to download the two models? Would you just, if you were to pull them in offline, put them there, I guess it should work just fine.
Because you can have the same tensor files and then physically on a disk deploying from there.
Thank you so much.